Welcome back to the College of the Environment Speaker Series. For those of you that are students in the class, I don't have much to say. We are in the middle. We have our rhythm. You come, you get things done. It's going well. Communicate with Bo or me if you've got other issues. Yeah, we're well into it. Today, I'm excited because I was very curious about this talk. Having seen a lot of beavers and a lot of marshy tidal areas, I had not thought to combine these ideas much. So yeah, we're welcoming Dr. Greg Hood. I will not get this right, from the Skagit River System Cooperative. So yeah, let's give them your full attention and we'll have 10 minutes for questions at the end. Take it over.
All right, thank you very much. So I want to start by saying, first off, thank you for inviting me. It's a pleasure to be here. And I've been doing work in the Pacific Northwest for about 35 years. And during that time, I've met a lot of Western Washington University grads who work for the federal government, or the state government, or county governments, or tribes, or other nonprofits. And almost without exception, they've been really outstanding people who do really good work. So I just want you to know, in case you don't realize it, your department has a very good reputation, and you produce great quality people. So it's a pleasure to be here and to give back a little bit in my small way to the education enterprise that you all are engaged in. So I want to talk today to you about beaver and tidal wetlands. And I want to say that I'm an accidental beaverologist. It was not planned. I was doing something completely different in tidal marshes when all this began. I was interested in vegetation distributions in tidal marshes and how logs, nurse logs, affected the abundance of shrubs in tidal marshes. And tidal shrub communities are kind of rare and unusual because that habitat has been destroyed disproportionately compared to regular tidal marshes. So I was going around looking at things like these big old logs. These are like, here's a stadia rod from a surveyor's stadia rod for scale. So this is about chest high log here with salal growing on top of it, which is normally an upland plant. And there's a big old alder growing out of it and some other smaller shrubs. This is probably black twinberry. Here you can see we're near high tide. The marsh surface is being flooded, and there's two logs. There's a log back here. It's being covered by sweetgale, and the log right here, there's also a little sweetgale shrub. So you can see the idea is that these nurse logs raise the plants up out of the water. That's why they can be there. They're not being flooded and drowned. So my hypothesis is that at low elevations, I would see very little shrubs and probably a few logs because it's so low elevation that the waves and wind and things like that are blowing the logs around and blowing them up higher into the marsh where they eventually get lodged, and then they're stable enough that shrubs can grow on them. And so I was walking these transects and expecting, not much shrub and not much log, and that's what you see here in these graphs here. These are my transects 1 through 8, going up from low to high elevation, and not much in the way of logs or shrubs. Sweetgale is a shade-intolerant plant, so I was expecting more of that. And then at higher elevations, it starts to be shaded out by things like black twinberry and wild rose and willow and stuff like that. So this is all a vegetation thing that I was going on. And here we have at low elevations, almost all the shrubs, 100% of the shrubs are growing on top of logs. This is the frequency of log occurrence on the transects. And you see the shrubs are disproportionately on logs and not on the bare ground. And then as you get higher and higher in elevation, they start to be less on logs, although still disproportionately on them, but they spread out vegetatively through vegetative growth into the adjacent marsh, right? And so, and this is just a little aside here, the average log size that they were growing on was was these bars for different species. And then this dash bar is the average size of the diameter of trees, Sitka spruce trees, that are growing in the tidal marsh. Right? And Sitka spruce trees are growing on nurse logs. So you can see the Sitka spruce trees don't get very big. They're about 32, 33 centimeters in diameter, whereas the nurse logs can be over 1 meter in diameter. And this is not just today, this is historically also. There was a study on the historical surveyors' notes from this area, and surveyors in the old days used to use trees as witness trees. Basically, they were their markers for angles, when they're turning angles with their surveyor's instruments, and they would note the species and the size of the tree. And so we have all this data from the 1860s, and it turns out Sitka spruce in the tidal marshes in those days were also only 30 to 35 centimeters in diameter. So all these nurse logs are not coming from trees in the tidal marsh, they're coming from upriver, right? So tidal marshes are connected to their basins, not just because of water and sediment, but also because of trees that are being recruited, logs that are recruiting to the tidal marshes that are affecting the distribution of vegetation in the tidal marshes, right? So that's what I was doing initially. And I was walking all these transects, and of course, as you're walking these transects, you're crossing tidal channels, and I would see these accumulations of sticks in the tidal channels, and I thought, is that just a random accumulation of sticks being brought in by the tides, or is that intentional? They look suspiciously like beaver dams, but I wasn't entirely sure. Now, are beavers in tidal systems? I don't remember hearing about beavers in tidal systems. And I started seeing more and more dams the more I was walking these areas. And it's like, okay, those look really like beaver dams. And then, you see things that are clearly, unequivocally beaver dams. And I saw beaver swimming in a channel one day, and I saw beaver lodges. It's like, okay, I'm convinced. It's not my imagination. These are really beaver. They're in a tidal marsh where the tides can be 3 meters, 11 feet, 3 or 4 meters, 11 to 12 feet in range. That's huge. But is there any literature on this? So I went to the library, I went online, Googled it, went to Google Scholar, looked for all the literature I could find on tidal beaver. There's almost nothing on them. There was a paper on beaver in the tidal marshes of the Rhine Delta, except the Rhine Delta is microtidal. Its tidal range is a few inches. And the focus was on heavy metal contaminations in those beavers. So it really wasn't about the ecology of beaver, and it was in a microtidal system that's not really tidal. And if you look through the various literatures, there's a mention here and there, like, oh yeah, we saw some beaver in a microtidal place. And that's it. They don't really talk, it's just an aside to something else that the paper is really about. So there's no literature on beaver in tidal marshes. I thought, oh, I've got something. And I went to a friend of mine who I went to graduate school with, Michael Pollock, who works at NOAA, and he is actually a real honest-to-goodness beaverologist. And I said, hey, Michael, have you heard of beaver in tidal marshes? And he said, no, they don't exist there. And I said, oh, I got news for you. And so, yeah, so I got excited because, hey, I have a story to tell that people don't know about. Here's a beaver lodge. And so I did some surveying back in the early 2000s, just mapping where beaver dams were. So I walked 25 kilometers of tidal channels. That's about 15 miles of tidal channels. And all these yellow dots, this is the South Fork of the Skagit Delta. All these yellow dots are beaver dams. All these black triangles are beaver lodges. The green, the light green here is sweetgill thickets. Sweetgill grows in almost a monoculture, and they're in thickets because they're thick. They're really hard to walk through, super hard to walk through, exhausting. And then the dark green are mixed species thickets. And these include Sitka spruce, but a lot of willow, black twinberry, wild rose, things like that. And they're growing at higher elevations. Often they're growing on the natural levees along these distributaries, right? And so as you can look here, you can see that the beaver dams and lodges are almost exclusively, not entirely, but almost exclusively in the tidal shrub habitat. Right? So this gets back to my nurse log beginnings of this and my interest in the distribution of tidal shrubs. It's like, oh, it's not, sweetgill is also a nitrogen-fixing shrub, which is kind of important in tidal marshes because they're a nitrogen-limited system. So it's like I was all focused on nitrogen limitation and sweetgill and blah, blah, blah. It's like, oh, they're important for beaver also, right? And all these red stars, you're probably wondering what these are all about. This is where I would either flush great blue heron or I would see their tracks in the bottoms of the tidal channels at low tide. And of course, great blue heron feed on fish. And so you notice there's not any red stars up here in the tidal shrub zone, probably because I think there's 2 reasons for that. One is that it's hard with that big wingspan that great blue herons have, these giant feathered pterodactyls, to land in an area that's bordered by shrubs, right? It's just hard to get in there. Secondly, and you'll see later on, that beaver ponds at low tide are pretty deep. And while great blue heron have long legs, they're not that long, right? So wading in some of these deep ponds is probably hard for them to do. So I suspect that beaver pools here at low tide are actually a predation refuge for these juvenile salmon that are growing in there, and I'll tell you more about those guys. So let me just give you some basic metrics here. One is that none of the tidal emergent channels, and tidal emergent is just a fancy way of saying that tidal herbaceous zone, basically the things that are characterized by sedges, is a grass-like plant that can get up to your waist in height, or cattails or bulrushes or things like that. That's in the tidal emergent zone, the tidal herbaceous zone. So almost none of the tidal herbaceous zone had beaver dams. There's a little exception right here, this beaver dam. And about 2/3 of the channels that I sampled in the tidal shrub zone did have beaver dams in them, right? And then you can compare the frequency of beaver dam occurrence, along a channel, and you see it's actually greater. There's more of them in a kilometer length of channel than there are in the normal places for beaver to be in fluvial upstream rivers of eastern Oregon or coastal Oregon or western Washington. And they're comparable to pristine North America. My buddy Michael Pollack wrote a paper about that. You can see here what the range is in different parts of North America. The lodges are also quite abundant relative to the normal place for beavers to be. And so, one of the issues that I've had when I talk to people, and especially scientists, about this, is they go, oh, tidal marshes, that's got to be a weird place and kind of stressful for beavers. There's probably, the Skagit's kind of a freaky place. Yeah, it's just a weird place, and they're not normally in tidal marshes. And if they are, they're not healthy there, and they're not eating very well. And it turns out that you see that the density of beaver lodges is quite high relative to these normal places. So that suggests to me that it's not a stressful place for them to be, that they're doing quite well. Now, one of the things they do with their dams is they quadruple the amount of low tide pool habitat, all right, relative to channels without dams. And then they triple the density of fish that are in those low tide pools. That's by volume. By surface area, which is kind of the traditional fisheries metric, it's 8-fold times as many fish, right? Here's some more detail on those pools. So these are pools at low tide, and I'll get to you. I'll show you why I'm specifying low tide. But the mean depth of pools that are formed by beaver. Here's our beaver pools in this bar, and they're in the tidal shrub zone only, and that's why it's green. The tidal herbaceous zone here are the blue bars. So I compared them in both habitat types. And these are pools formed by beaver dams, pools that are formed at the outlets of these tidal channels because there's a little swirling around there at the outlets, little complexity of flow, and so you get a little scour sometimes, not always. They're formed by large woody debris, which is a scientific way to make things complicated when they really just mean logs, right? You got to sound sophisticated. So you get scour around some of these logs that are in the channels, and you get little pools there. Oh, and by the way, these numbers are my sample size. So here I have 90 beaver dam formed pools. I had 6 outlet formed pools in the herbaceous zone and in the shrub zone and the herbaceous zone and so forth and so on. There are pools in meander bends because you get scour on the outside cut bank of the meander bend. There are some pools that were unclear. They weren't associated with anything, and I suspect that those are where logs used to be and had a scour, and then the log at some point got loose and floated away and left the pool behind. And these pools, as you can see, are a little bit smaller than the ones with logs, which suggests that maybe the log went away and then the pool started filling in a little bit. Bank slumps. Sometimes the bank will slump in the tidal channel, and you'll get a pool behind that because it's a little bank slump dam. And then tributary junctions. You'll have a tributary to a tidal channel, and you get a little scour there where the junction comes in. The pool length, well, actually, the statistics here just show you that beaver pools are deeper. And there's a statistical test here, a very simple, t-test or paired sample t-test. And, pools are way, way, way deeper. And then pool lengths are about triple the length that you see of pools formed by other structures. So beaver are having, they're an ecosystem engineer, and here they are engineering in this ecosystem too. So I mentioned fish, juvenile Chinook are growing in these pools at low tide. So I went out there with some nets. I would block off a section of channel with, a blocking net at one end and another blocking net at the other, and I would go through with a stick seine, and I would just catch all the fish, put them in a bucket filled with water, and then go through and seine again, and put them in there. And of course, with every pass of the seine, I should get fewer and fewer fish. And you can graph that. It's called depletion seining, and it's a negative exponential curve. And from that, you can estimate the whole population of fish that you're sampling, because if you're not catching all of them, you can at least extend the graph to 0 and see how many there are. And so what you find out is that there's 3 times the density of Chinook, juvenile Chinook, in these pools by volume. Sticklebacks, a really common fish out there. There's 2 times the density in those pools compared to shallows by volume. Prickly sculpin, a very common estuarine, small estuarine fish, really super abundant there in those pools. River lamprey, funny little story about river lamprey. The juvenile river lamprey bury themselves in the sediment and they're filter feeders. Okay? So when you take a seine and go through there, seines have a lead line on them to keep the net on the bottom. When you go through there with that seine, you stir up the sediments. And so with every pass, you get more and more lamprey. And so you don't have a declining exponential curve. You have this curve that goes up. And so mathematically, you have an infinite number of river lamprey in these pools. So there's just a lot of them out there. I don't know how many, there's just a lot. The other thing you find out when you're taking these seines through these pools is that in the tidal shrub area, the seines are full of muck. They're full of leaves, they're full of sticks, it's just choked with them. And you notice this because it's hard to find the fish. You have to pick the fish out of all that muck, all that detritus. Whereas in the herbaceous zone, your nets are nice and clean, and it's just so easy to find those fish and pick them out. Why is that a big deal? Well, because all this detritus, all this organic material is food for invertebrates that are detritivores, that eat that stuff, right? And all those little invertebrates, like chironomid flies, larvae of chironomid flies, those are yummy food items for juvenile fish. So these beaver pools probably are producing a lot of food that are being yummily gobbled down by small fish. Now, I haven't actually gone out there and measured that. That's just an observation, like a little, seems likely. I'm like 99% sure that if I go out there and measure quantitatively, benthic invertebrates as well as the organic material, that I'm going to see a very distinct differences, something I do plan to do. So to summarize all this into a nice little cartoon, we have upstream river management that is producing big old logs that come down the river and wind up in our tidal marshes. Those are nurse logs for sweet gale and willow and all kinds of other shrubs. Those are gobbled down by beaver. They really love willow. And they use all that material to build their lodges and to build their dams, right? So they really need this stuff. And that creates low tide pools that influences things like predation, refuge, and detritus trapping and prey production, which in turn benefits juvenile salmon. Right now, so as I mentioned, I presented that information a few years ago to people, and people would say, oh, the Skagit's a weird place. It's only in the Skagit, because beaver really don't like tidal systems. And so recently, with the improvement of aerial photography and imagery, especially in Google Earth, I decided, well, let's just go see how common these guys are elsewhere in the Northwest. And so this is a map of all the places where I've looked on air photos and found beaver dams. And here's a Fraser Delta example. This is low tide. It's a lovely photograph, really clear. You can see that the tidal channel is bare mud, with except the little foul weg here, the deep little residual channel there that has some residual water at low tide. And then you hit this beaver dam, and boom, you have a lot of water. It's like, this is obvious. You can look at this, and it's just really obviously clear. And there's another little dam up here. And you can almost count the logs in the beaver dams. That's how good these photos are. And then these are all other areas where I've seen in the air photo beaver dams, and I've gone out in the field and ground truthed this. So I went out there. This is near Ladner, British Columbia, and you can walk out to this marsh. And then I have a colleague who went out in a kayak out here who works for Ducks Unlimited Canada, and that's his kayak there, and a photo that he took of it's a little breached dam. And I'm going to show you some other spots here. This is down in the Chehalis estuary. This is where I did my dissertation work. And you can see these beaver dams just jump out at you. They're really obvious. Again, you can almost count the individual sticks in these dams. I went out there and stood at this spot right here and took a picture down through here, and that's what you see here. There's a beaver dam right here. That's this beaver dam. And this in the distance is another beaver dam. That's this one down here. And then when I look to the left over here, I saw that beaver dam. And initially, I didn't think that was a beaver dam because I thought, well, maybe it's just some shrub that's leaning over the channel, you know, because you can't actually see sticks there. But it's sedges that are growing on top of the beaver dam. So they'll get packed with mud, and so they can get colonized by vegetation. Here's the Columbia River. This is just upstream of Astoria. Astoria is just off the frame here. And, you know, I counted 248 beaver dams, and I think 5 lodges. Lodges are harder to identify well. And that's not all, there's probably 3 to 4 times as many beaver dams that I don't see because they're under the canopy of shrubs. Here's a close-up. This is the Columbia River. You can see at low tide, the banks are exposed. And this channel is really shallow water right here. And also you see the banks of it are exposed at low tide too. But you hit the first beaver dam, and all of a sudden the water's wider, and it's up to the edges where it's vegetated. And then you hit another beaver dam, and another one, another one. And what I'm missing are probably beaver dams up in these smaller channels that are under a canopy. These are harder to see. And the nice thing about having aerial imagery now and being able to be reasonably certain that when I see a beaver dam, it really is one, because I've been out in ground truth almost all of those areas in there, is that now we can get an estimate of the age of the beaver dam. And it's a minimum age, right? It could be older because the photographs prior to 1990, you can't really, the resolution is so terrible that you really can't see beaver dams in them. And in 1990, even then, it's only like really wide channels with really big beaver dams can I be certain, oh yeah. And that's only because then I look at later photographs and I still see a beaver dam in the same place. It's like, okay, that really is a beaver dam. It's not my imagination, right? And so what we see is that beaver dams can be as much as 35 years old in tidal systems and probably older. And it turns out that the average lifespan of beaver in the wild is 11 years. So that means these are multi-generational dams, right? Grandchildren and great-grandchildren are taking over these dams. So probably good habitat. Now, that first set of beaver dams that I showed you that I mapped, I did that the old-fashioned way without RTK GPS. I went out there with air photos, and I would navigate by the air photos, and I had a hip chain, which is basically a spool of string that you attach to your hip, and you walk around, and it spools out, and it has a little counter on there, and it counts how far you've walked, right? And so that's how I would map my way around these dams. And then I had a stadia rod, and I would measure the depth of the water with it's just a big ruler stick, right? Measure the depth of the water with the stadia rod, and then to measure the height of my dams, I took the stadia rod, put it flatwise, and I had a little bubble level, and I would get my stadia rod leveled, and I would measure from the stadia rod down to the bottom of the pool, and then to the top, you know, and the top of my dam is 0, so I get a head difference. This, you know, simple, low-tech field work. Nowadays, we can get there with an RTK GPS, real-time kinematic GPS. It measures within 3 centimeters of horizontal and vertical. And so I'm going to show you some of that data because it's really groovy. You can see some cool things that you can't otherwise see. Anyway, what I show you here first off is this is the Quilceda Marsh in the Snohomish. This is Heron Point, also in the Snohomish, a little further upstream. And this is Otter Island in the Snohomish, a little further upstream. This is the North Fork of the Skagit, okay, which I hadn't mapped before. And all these red dots, as you can imagine, are the beaver dams. All the triangles are beaver lodges, because that's basically what lodges look like. And then this star is a scent mound. And I had never seen scent mounds before. I'd read about them. But they're basically little mini dams, mini lodges. They're little mounds made out of organic material. And then the beavers spray them with, you know, their scent glands. And that marks their territorial boundaries. So it's like, go away, this is my spot, you know. And I think the reason I don't see them so often in tidal marshes, I've seen them in 2 places in tidal marshes, so I think that high tides just wash away the scent, right? So it's not going to stay around very long. It might, you know, a couple of weeks, you know, during the neap tides, the low tides, the lower tide series, not the high tide series, the spring tides. And so I think that's why you don't see them very often. And they have to be at relatively high elevations, even in a tidal marsh. Anyway, so as you can see, there's a lot of beaver dams, not just in the special magic Skagit, but also in the Snohomish, right? And here I think this visually really illustrates what's interesting about tidal beaver dams. If you walk up these channels here, these yellow lines are the channel traces of my survey route. And this top graph here is for this top channel. This bottom graph is for this bottom channel, and the same thing over here. This channel, this top graph is for this leftward channel. What you see really clearly in these Quilceda marsh channels is that where I don't, well, let me back up and just decode the graph here for you. This golden line is the channel bottom, because it's the closest color I could get to being muddy brown without being an ugly brown color. And then the blue line, of course, is water. So this is the water surface elevation at low tide. The green line here is the marsh surface. So this is the bank elevation of the channel. And this dashed line is mean higher high water. So this is the average of the higher high tides that you get each day. Okay? And this is typical for tidal marshes. Their elevation is typically at mean higher high water. And so what you see here is that low tide, where I don't have a dam, there's just a trickle of water. It's like a couple inches deep. And when I hit the dams, we start getting pools behind those dams, and they stair-step the water level up. All right, we're stair-stepping it up, and we stair-step it up to the height of the marsh surface. And so at high tide, these dams are being completely overtopped. Right? Even the highest dams, because this is average higher, mean higher high water. There are tides that get higher than that, and they overtop even those dams, right? So one question I sometimes get is, do fish ever get trapped behind the dams? Well, not in tidal systems, because during high tides, if they want to, they can leave. And during low tides, without a dam, you get flushed out of the channel. So get out of there. You have to go to the distributary, to the river, and get flushed even further downstream, probably. So at low tide with a beaver dam, you can hang out as long as you want. So your residence time, the time you spend in the marsh, and the time you spend growing there and feeding, increases probably. I haven't measured this, but logically, I mean, I see fish in these pools, their residence time is clearly longer than fish that aren't in those pools, right? And the other thing I want to say about this is that, well, for example, here in the North Fork, we have beaver dams going all the way down to the river distributary. This is the river distributary down here. And because the shrub line goes all the way down to the river distributary. You see these, you can see pretty clearly these shrubs here, these darker green things. And so these beaver can swim around at low tide. I think these beaver dams are not just about raising the water level up high to where it floods the entrances of their lodges. Their lodges, let me back up a little bit and explain to you what lodges are like for beavers. They're a pile of sticks, right? A big pile that's probably about this high, over my head, out there in the marshes. But their entrance is there's a tunnel from the surface of the marsh underneath the pile of sticks. There's a tunnel that's kind of J-shaped out into the channel, and so it's underwater, right? Because that way they avoid predators that don't go underwater. And so they like to have that water raised up during low tide so that their entrances are flooded all the time. So that's one reason why they have these dams. They raise the water up to keep their lodges nicely safe. And sometimes they'll actually build a moat. They'll excavate a moat around their lodges so it's surrounded by water on all sides. And they can also excavate some channels. Well, actually, you see that in this photo right here. Some of these channels here are excavated by beaver dams. I mean, by beaver, excuse me. And so they have a little moat, a little ring moat around here, and all these channels some of these smaller channels are excavated, and that allows them to take a little foray out to this patch of shrubs and eat some yummy shrub and also use it for building material. And also, they don't just eat shrubs, they also eat herbaceous material, so it allows them to have little, navigation routes, different navigation routes. But the other thing I think these dams do is they allow them to simply swim around at low tide, right? So they're not just homebodies, because beaver do not like to walk. They like to, they feel uncomfortable, they feel vulnerable walking. They like to swim. And let me just show you an example of this, kind of an extreme example, and I need to tell you a little story about this. This is the North Fork here, and this red photo is an infrared orthophoto of the North Fork taken in 2004. And this colored photo, true color photo, was taken in 2021, I believe. And there was an avulsion. An avulsion is when a river switches course. So there was historically, it's off the edge of this photo, unfortunately. There was a blind tidal channel that came up through here, and the river was cutting into this cut bank, and it cut into that blind tidal channel. And that blind tidal channel was shorter, a shorter distance to Skagit Bay than its old main stem. And so the slope of the water was steeper going down this shorter route than it was going down this longer route, right? Because you're going from this elevation of water here to sea level, which varies with the tides, but whatever. You're going from, so your change in y here is versus your change in x, right? So it's just slope, delta y, delta x. Your delta x is really long going this route, and it's really short going this route, so it's steeper. And so water goes down the steeper flow path. That became the preferred route. That became the new main stem. It got wider and wider and wider. In 2004, I could step across that channel, right? And now it's like, I think it's like nearly 100 yards wide, right? So it's been dramatic. It's been really interesting, fascinating to see this happen. This, geology is actually not that slow sometimes. And what's happened is because of that, most of the flow is going here. The flow is decreased here, and so the sediment that's suspended in the river is dropping out, and it's filling in this area here. So you can see this area here is the same as this blue area in this photo here. This was flown at low tide. This red photo, right? So this is all filling in with sediment, and the sediment's being colonized by vegetation, a lot of shrubs actually, because it's sandy stuff. It drains well. And so, and these distributaries, you can see these blue lines here. These are distributaries. So a distributary, just in case you're not familiar with the term, is the opposite of a tributary. Right? A tributary flows into a river. Distributaries flow away from a river. The tributaries are like, it's like a river's basin is like an hourglass. The upper part of the basin is all tributaries flowing in to the river, and the delta is all distributaries flowing away from the river, distributing water, distributing sediment, distributing fish over the landscape. Okay, so these distributaries are also filling in, and this is what you see here. And these beaver dams here along these traces, these surveyed traces, are being built in these distributaries, and you can see mean higher waters up here. The bank of these channels are narrowing because they're filling with sediment, and they're not yet raised up to the elevation of a mature marsh. So our green marsh level here is not yet as high as the mean high water. And so we don't have any lodges along these channels. There's no reason to be building dams here if you want to try to flood a lodge, because the lodges are not adjacent to the channel, and lodges have to be adjacent to channels because they swim to them, right? They don't walk to them over the marsh surface. And so these dams are all about the beaver being able to swim at low tide through these distributaries. They don't want to be homebodies at low tide. They want to be able to get around at all tides. Right? So high tide, no problem. Everything's flooded. They can swim around. Low tide, they need dams to be able to get around. And this is just a little bit of, scientists like to count everything and then do some graphs and preferably some statistics too. And this just shows, like, a lot of these lodges, how connected are they to different movement pathways. And if you're a lodge on a distributary bank, there's really only two movement pathways. There's upstream and downstream. But if you have a fork in the distributary, and you're right there at that fork, now you've got three pathways. You can go down this distributary, or you can go upstream and downstream. Or you have a blind tidal channel that's connecting right close to your lodge. Now that's another movement pathway. You can go up the blind tidal channel. So I counted all these movement pathways, and these are distributary channel lodges, and they're a little more constrained than blind tidal channel lodges, because there you get some pretty complex networks and all kinds of tributaries coming in close to each other near a lodge. And this lodge is the one that I showed you earlier that had the ring moat and had the excavated channels around it. They can artificially excavate some of their channels and increase their mobility. And then this is a comparison of the spacing of channels, of dams along channels, and relative to channel length. And I just want to focus on, this is the Snohomish right here, these gray dots, and this is the North Fork Skagit. So the spacing in the Snohomish is greater than it is in the Skagit. And I think, I don't know for sure, but I think this has to do with the sediment quality in both systems. The Skagit is a very sandy system. It's a very steep basin. The Snohomish, not quite as steep, and there's a big, long floodplain area that is low gradient and allows heavier sediments to settle out, whereas only fine sediments keep on going down to the estuary. And so you have finer, more cohesive muds down in the estuary. And so I think when it comes to building a dam, a dam is not just sticks, it's also mud or sediment that's packed in there with the sticks. And so I think that with those kinds of sediment differences, you can build taller dams and space them further apart. And that's what we're seeing in this data here. Whereas with the sandier kind of sediment, the dams will fall apart, they leak more, and so you have to have smaller, lower dams, but more of them to stack up the same amount of water. Something else I should mention too, there's so many things to talk about beaver dams. Like human dams, there's always a threat to the dam of leakage, right? Dams, all dams leak, even human dams leak. I didn't know this because I'm not an engineer, but I did a lot of reading about it because I was wondering about what's the comparison of beaver dams with human dams. And of course, the taller your dam, the more pressure, water pressure there is on the dam, and the more leakage there is, right? And that's the same going to be, and of course, the more leakage you have, and if a leakage gets severe, it can cause catastrophic dam failure, right? Boom, the dam just blows out. And so that's true with beaver dams too, right? So I was wondering, why don't beaver just build one big giant dam at the mouth of the tidal channel and be done with it? Well, I think it's because those dams would be prone to failure, right? And so you have a bunch of smaller dams that are stacking up that water, but each individual dam has a limited amount of water pressure. But collectively, they can stair-step that water up to the marsh surface and flood at least, some portions of the marsh quite extensively. And this, I think, is just interesting, is that there's regional variation. There's probably even variation along a channel in building material quality, and which probably might be contributing to some of the variation in dam sizes along a channel. Now, I want to talk about some unusual tidal beaver. Like you thought tidal beaver were weird, they can get even weirder. So these are a couple of systems that are, Red Salmon Creek is a tributary to Red Salmon Slough in the Nisqually Delta. Okay, and Red Salmon Slough isn't part of the Nisqually River. That's a separate thing. They're adjacent. They're near each other, but it's not a river. It's a slough, right? East Fork Redmond Slough is a tributary to the southern shoreline of Grays Harbor. Okay, it's a small little thing, and Potter Slough is similarly a small little tributary to the Willapa River, the tidal Willapa River. And what's interesting about them is I went out there to ground truth these aerial photographs, and I was very surprised to see that not only were there beaver dams in the channel, that was not surprising, but there are beaver dams on top of the marsh surface. That's what these red lines are. So these beaver dams were anywhere from, well, they're typically around waist high on top of the marsh surface. And so what I think is going on here, one of these are small systems. There's not much freshwater inflow. There is some. There's little streams that come in up at the upstream ends of these things. But it's a relatively limited amount of freshwater inflow, and you're right up against seawater, saltwater. Actually, this is Netart's Bay. This is an even more extreme example. This is on the Oregon coast. And, this is Netart's Bay at low tide. This is all this is ocean salt, But there's a little stream up here, can't remember the name of it, that pops in. And we have Beaver Dam on top of the, in the channels, but also on the marsh surface. And so what I think that does is that it retains all of this fresh water and it freshens up the marsh. Because beaver do not like salt water, right? They need fresh water. They can die of salt poisoning if they imbibe too much salt water. And so it's ponding up this freshwater inflow and kind of maximizing the influence of that freshwater input on the vegetation community around the marshes, turning that what would otherwise be a saltier community into a fresher community. And it's maximizing their ability to move around in these big old ponds and feed on aquatic vegetation. So yeah, that was a huge surprise to me. which to me illustrates also the importance of like not just relying on a kind of a flagship kind of system like the Skagit or the Snohomish. You got to look around and look for variation in the landscape and see how do things change all over the landscape. And these small little systems are probably behaving in a different way than the really big systems that have a lot of freshwater inflow and are. Anyway, I've got 5 minutes, so I've got to rush through. I think this is near my last slide. One of the exciting things I'm doing right now is I'm collaborating with some folks from the Tulalip tribe who are beaverologists, the real honest to goodness thing, not accidental ones like me. And we've been trapping beaver in tidal systems, which is tricky because you don't want to drown them at high tide. So we go out there in a neap tide, not quite so high tide. We set our traps at high tide, at high elevations. We trap them, and then we've been putting RTK GPS tags on the beaver. We've been gluing them to their backs so they don't have necks, so you can't put a collar on them. And they have, this is the range, the resolution basically of the signal, so the accuracy of the signal. So that's what that circle is supposed to denote. It's the radius is 9 meters, and these are our points. And you do a little cluster analysis. We captured the beaver here and released him here, and then he spends a lot of his time in these two areas which you don't really know anything about. We didn't expect him there at all because these are old farm sites that it breached ages ago. And this triangle is where we mapped beaver lodges, another beaver lodge right here, which there is some activity there. And there's a beaver lodge here we didn't know about, but with all these clusters, we went in and inspected. It's like, oh, there's a beaver lodge, that's why he's there. And there's some occasional excursions for adventuring and exploring, maybe. If you try to, the minimum connectivity for all these activity points is about 4.7 kilometers, which is comparable to the movement range in normal beavers and normal river fluvial habitats. So they're not different, they're not being weird. The range is typically an estimate of people in fluvial systems say of habitat quality. If they don't have to move so far, it's really good. If they have to move a lot, then it's not so great. This is comparable to fluvial systems. And I won't go into all the detail here over on the side. That was just breaking down the data by day. But what's interesting is by vegetation community, they're spending most of their time actually in herbaceous vegetation communities, not most of the time in the shrub community. They are spending time there, of course, it's important, but the herbaceous community is also apparently really important for them. So anyway, I'll just say that to summarize, tidal beaver are much more common than people realize, even beaverologists. We don't know as much as we think we do, and partly because of historical amnesia, right? These vegetation communities mostly are gone in our landscape, and we don't know how those historical landscapes used to work. And this is work by Brian Collins to reconstruct those historical landscapes from those 1860 surveyor's notes. And you can see this is today in the Skagit. The gray is all farmland. The dark gray is cities. These are all different kinds of wetland habitats. And there's lots of really interesting questions. Like science, the wonderful thing about it is that the more you learn, the more you wonder why, and like what's going on. And there's all these really fascinating questions to continue on with. So I will leave it there with any questions. Thank you.
We have about 6-7 minutes for some questions.
Yes. 13%. Oh, spruce trees, right? You can take a photo, Oh, there you go. That too. But I get lazy at talks when I see a really interesting slide. I take a photograph of it. I'll leave that up there for folks who want to take a photo of it. Yes. About 11 years. Yeah. Now in the captivity, they can live for about 30 years. So, yeah. But predation is a big part of of their shortened lifespan. Predation, it can be by wolves, for example. That's a common one. Probably coyotes in our system. Bears, and we do have black bears. Not so much in the Skagit or the Snohomish. I don't think in the Snohomish. In the Chehalis, I saw black bears on numerous occasions when I was out there. Yes, there's by the wall. There's a. Are those? Is that an online question?
Yes. Reminder, if you could repeat the question before you answer it
Oh.
for the online folks.
Sorry.
Then, can LiDAR used to detect Beaver Dam? And then do you have a story about the hardest, most tedious, most muddy Beaver Dam ever tried?
I have not looked at LiDAR to see if they can detect beaver dams. I think it would probably have the same kinds of problems as looking at visual imagery, because while LiDAR theoretically is supposed to be able to, produce bare earth, in reality, shrub cover and tree cover actually obscures a lot of that bare earth and creates some errors in the estimate of where bare earth elevations are. So I think you'd have similar problems. And so far, like I say, I haven't tried it, so maybe it might work better than just looking at visually at aerial photographs. See, what was the other question? Oh, muddy, the muddiest, most complicated. Well, there are some challenging times. A lot of these beaver pools fill up with sediment to some degree, at least. They trap sediment. And if you're trying to walk through them, one, they can be very deep even without the sediment, right? They can be, over a meter deep. But if you add some sediment in there, soft, unconsolidated, trapped sediment, now you can sink into that sediment. It looks shallower than it is, because you can sink into, and so there have been times when I've had to grab a shrub on the side of the bank, and I'm wearing chest waders, there's a limit to how wet I want to get. So yeah, it can be challenging sometimes. Oh, hang on, I'll go with you first. Yeah. Well, like I said, okay, the question, are fish able to move through beaver dams? In tidal systems, they can move over them, right? Because at high tide, the dams are flooded. Now, in fluvial systems, that's not an option. And, you all, well, no, you all, I forgot for a moment that I'm not in Seattle. In Seattle, there's a park called Carkeek Park. It's right on the Sound. Some of y'all familiar with it? Great, I see nodding heads. They've got a massive beaver complex there. It's really cool. And they've got a boardwalk that takes you into it also. And I was out there this past autumn, and chum were coming back because they spawn in Piper's Creek there. And you could see them going up through the dams. And so it was interesting to watch how they do it. They'll go through an area where there's a lot of flow going over the dam, and they'll swim right up that flow. And now there are some areas where they'll go around. It's like, oh, no, because the dam complex is big. These dams are really wide. They can be tens or 20, 30, 40, 50 yards wide. And there's more than one route up the stream, because the stream is not a single thread when you have all these, and that's normal actually, in pristine systems. And so they'll go up one stream, and it's like, I can't get through here, so they have to come back down. They'll try another route, and eventually they'll find a route where they can swim up. That's where things aren't so difficult. So it's fascinating to watch. Now, most of the time, adults can get past dams, and juveniles for sure. Sometimes they can swim right through them because of gaps in the sticks. But there are occasions when dams are impassable, but I think they're a minority of the occasion. Drew, I think you had a question?
You found any beaver dam on any tidal restoration sites?
Yes, not intentionally. They weren't intentionally, so far people are not intentionally targeting beaver for tidal restoration sites because it's such a new thing. What I have seen is in old restoration sites, typically things there's some places in the Snohomish, for example, that are decades old. And usually they weren't intentional restoration. They were dike failures that just wasn't economical to fix, right? And so they just abandoned the properties. And so there you can see some beaver dams on those old places, which suggests that, yeah, beaver can, reoccupy places that they were previously completely wiped out from because the habitat was completely wiped out. So if the habitat comes back, now I've measured, there's a restoration site which is also initially a dike failure site in the Skagit called Milltown Island. And the beavers are, I think, 1/3 the density that they are in the natural marshes. So they're quite abundant, but they're not as abundant. And so I suspect that's because that was a failure site. It wasn't a planned and well-designed restoration site. And so we're not maximizing the value of those sites for beaver at this point. I think if we do a really good job, we have the potential to do so.
I think we're actually out of time, but I'm sure Greg would be happy to answer some questions up here. But yeah, thank you very much.
Yeah, my pleasure.